In 18th-century London, a homeowner commissioned a bizarre architectural modification to his estate. He ordered carpenters to build a secret back staircase, designed for one specific purpose: to allow him to move through his own home without ever accidentally encountering his own housekeeper. The man requesting this isolation was Henry Cavendish. Descended from the Dukes of Devonshire and Kent, he was the largest single depositor in the Bank of England. The French physicist Jean-Baptiste Biot famously described him as the richest of all the savants and the most knowledgeable of the rich. His wealth was matched only by his severe social aversion. Cavendish could only speak to one person at a time, and only if the person was both male and highly familiar to him. He communicated with his female servants exclusively by leaving handwritten notes on a hall table. Reviewing these contemporary accounts today, neurologists suspect he may have been autistic. Henry Cavendish possessed the financial power to dictate every aspect of his environment, yet he was terrified of the people in it. He spent his life actively hiding from human society, while dedicating every waking hour to decoding the physical laws that govern our shared reality. Inside his heavily modified home, Cavendish operated an extensive laboratory. Lacking any interest in socializing or making a name for himself, his singular drive was to weigh, measure, and quantify the physical world with absolute precision. Looking at this diagram of his 18th-century laboratory apparatus, we can see the exact physical tools he used to pull invisible gases apart. By dropping specific acids onto metals, he captured a highly reactive gas he called inflammable air, what we now know as hydrogen. He then observed that burning it produced pure water, proving that water was a chemical compound, not a basic element. In 1785, he turned his attention to the atmosphere. He repeatedly sparked electricity through a mixture of ordinary air and hydrogen to remove the oxygen and nitrogen. After hundreds of careful trials, he noticed a tiny, stubborn bubble of unreacted gas always remained, amounting to exactly 1/120th of the original volume. The instruments of the time were incredibly crude. Other chemists would have written off that microscopic bubble as a rounding error. Cavendish meticulously recorded it. It would take a full century before scientists possessed the technology to identify that exact bubble as a newly discovered noble gas, argon. He refused to ignore data that failed to fit neat expectations. This extreme fastidiousness established a new standard for quantitative chemistry, pushing human observation to thresholds that were decades ahead of their time. By 1797, Cavendish had moved most of his instruments to an estate in Clapham Common. He was 66 years old, and he was preparing to attempt an audacious measurement, determining the average density of the entire planet. This schematic shows the massive torsion-balance apparatus he used. A wooden arm suspended from a wire holds two small lead spheres. He placed two massive stationary lead balls nearby. Their microscopic gravitational pull would twist the wire by a fraction of a degree. The gravitational force between these objects is incredibly weak. Almost any environmental factor could overwhelm it. A slight draft in the room, changes in magnetic fields, or even the radiant feet of Cavendish's own body standing nearby would ruin the mechanics. To isolate the variables, Cavendish completely sealed the apparatus inside a closed room. He installed external controls to move the heavy weights from the outside, and he read the microscopic movements of the torsion balance by looking through telescopes mounted through the walls. To measure the faint gravitational hum of the Earth, he literally had to lock himself out of the room. True objectivity for Cavendish meant erasing his own physical presence from the act of observation. After nearly a year of remote observations, he calculated that the Earth's average density is 5.448 times greater than that of water. Today, with advanced seismology and satellite data, our accepted value is within 1% of his number. You will often see this described in textbooks as the moment humanity weighed the Earth, or discovered the universal gravitational constant, big G. But Cavendish never claimed either of those things. His explicitly stated goal was strictly to find the Earth's density. Once you have that density, however, a trivial web of algebra allows you to directly calculate the mass of the planet and the gravitational constant. He accurately defined the physical makeup of an entire world by tracking an attraction so slight it amounted to a mere 1/50 millionth of the weight of his lead balls. By obsessively micromanaging the climate of a single sealed wooden outbuilding in London, he effectively captured the mass of the planet. Cavendish died in 1810. He left behind an immense financial estate, no close personal attachments, and only a handful of published papers to the Royal Society. Nearly 70 years later, the Scottish physicist James Clerk Maxwell began sorting through the boxes of Cavendish's private, unpublished manuscripts. What he found inside those journals stunned the scientific community. Decades before the accepted pioneers of physics did their work, Cavendish had already formulated Ohm's law of electrical resistance, Coulomb's law of electrostatic force, and the foundational mathematical principles of thermodynamics. The history of science had to be entirely reevaluated. The world had lost almost a century of physical and chemical progress simply because its sharpest mind had kept his homework locked in a desk drawer. Why would a man exhaust his life documenting the exact mechanisms of the universe, only to hide those answers from everyone else? The answer lies in the exact traits that made him seem so eccentric. Cavendish was completely detached from the human desire for prestige, legacy, or peer validation. He didn't measure the earth to impress his contemporaries. He measured it for the purely private satisfaction of knowing the truth. To correct the historical record, James Clerk Maxwell ensured that the new physics facility at the University of Cambridge was named the Cavendish Laboratory. It would go on to become one of the most important centers of discovery in the modern world. Henry Cavendish spent 78 years actively retreating from society. Yet in his profound isolation, he laid the mathematical and chemical foundations for how we understand the reality we all share.